Okay, so yesterday we have discussed about the limit states. Okay, so yesterday we had discussed about how to design a building study that in detail step. Okay, if you are designing any step, so first one is coming to the first of all we are discussing. Okay, so today we are discussing that during the design of a structure, what are the steps that we need to follow? First one is you have to calculate the weight of the structure, big weight. Its weight will be very heavy. Okay, so definitely you have to calculate its self weight. That self weight is called as dead load, because why it is called as dead load means it is not moving, it is a static. The dead load and all the load that is acting, the people will be coming, people will be going. Okay, there are so many benches will be there, so many desks will be there. Okay, table will be there. Okay, so that load you have to calculate, so that is called as externally applied load. Okay, that means all the moving loads, even including us. Okay, the people are coming and people are going inside. Okay, so that is a moving load. A load is coming inside and load is going outside. Okay, so that moving load is called as externally applied load. Okay, so it is also called as live load, or you can say imposed load or superimposed load. Okay. Okay, for example, if you're designing a car parking. Okay, if you're designing a car parking structure, the cars will be there. Okay, imagine there'll be one, two, three cars will be there. Okay, there will be motorbikes will be there. Okay, so different types of vehicles are coming and going outside. So that load also you have to calculate the how much load that structure is imposing on the beam or corresponding column or slab. Okay, so how much of load is that particular material is imposing on the structure, so that is called as live load. That is mainly moving load, or you can say externally applied load. Okay, so that's the first thing that you have to calculate. Second one is you have to determine the design load for the different combinations of the load. Okay, so not just dead load and live load, you should also consider the wind load. If the structure is more than 10 meters, the wind, as you go up, the wind density will be very high. So wind pressure will be very high. Okay, so if you're going to more than 10 or 15 meters high, you have to consider the wind load. At the same time, you have to also consider the earthquake load. Okay, earthquake is also imposing a certain amount of forces on the the snow load in cases like for the countries like Canada or London, where you can see the ices on the. So different into our state, we have to take 2-story building which is having a great height like 20. Okay, so in
Yes,
our area,
yes,
this much is required. Okay, you have to consider
yes, sir.
one second. Okay, ഇപ്പോൾ കട്ടാവുന്നുണ്ടോ? Can you hear me now? Okay, okay. Okay, thank you. Okay, we were discussing about different steps that you have to consider. Okay, so first is you have to consider the design load. That is, at which load you have to design. Okay, so there will be different combinations. That load will be there, the live load will be there. Okay, then wind load will which combination you have to select. Okay, that's the second thing you have to see. Third one is you have to estimate the structural response due to design load. That means if a load is acting on a structure, what will be its bending moment, its shear force, its axial thrust, all these things you have to calculate. That is called as the structural response. And lastly, the fourth one, you have to determine the cross-sectional area of the concrete and amount of steel bar that is required. That is, depending upon the bending moment, shear force, and axial thrust, you have to find out the width, depth, and breadth of the concrete sections. That is, whether it is a beam, you have to find out the dimensions of the beam. If it is a column, you have to find out the dimension of the column. Okay, again break on the. Okay, and also you have to find out the steel reinforcement that is required. Okay, so next is limit states. Okay, next is limit states. ഇപ്പൊ കേൾക്കുന്നുണ്ടോ നിങ്ങൾക്ക്? ഇപ്പൊ ബ്രേക്ക് ആവുന്നില്ലല്ലോ. ഓക്കെ, ഇടയ്ക്ക് റേഞ്ച് വന്നും പോയിട്ട് ഇരിക്കുന്നുണ്ട്, അതുകൊണ്ടാണ്. ഓക്കെ, What now? Am I audible now? Can you hear me now? Okay. Okay. Okay.
Miss Missing a microphone.
What about now? Is it good now? Am I audible now?
Yes, miss.
Okay. So coming to the next one, that is partial safety factor. Okay, so partial safety or the loads. Why we are considering partial safety factor means, suppose I'm designing a structure.
മിസ് നേരത്തെ പറഞ്ഞൊന്നും കേട്ടില്ല. നേരത്തെ മൈക്ക് ഓഫ് ചെയ്യുന്നു.
20 Newton per mm square. But due to aggravate was not good, or sometimes the cement quality was very less, or the steel is very of poor quality. Okay, due to some defects in the sides, I am unable to reach. That is my so that it not always the target strength will be achieved. Okay, because in construction site there will be different types of from maybe due to climatic reasons, maybe due to the defects of the materials, maybe the person who is supervising is not good. Okay, so all these things can happen. Okay, so the target strength is not achieved, so these things you have to consider. Okay, so there is a chance of deviation of the value. Okay, there is always a chance of deviation of target strength due to different types of what to say different types of errors that is occurring in the site. Okay, so to account these errors, you are multiplying the load with a partial safety factor. That means we are always expecting a certain amount of error at the site. Okay, to counteract this error, we are multiplying the loads with a partial safety factor. Okay, that is, for example, I can say partial safety factor. For example, it is a 20 target strength. Okay, so I am multiplying with the factor and I am making into 22 Newton per mm square. Okay, I am taking it to 22 Newton per mm square. Okay, so I am mixing the concrete to get a strength of 22 Newton per mm square. Okay, so once after the structure is built up, I can see that maybe now I have reached a strength of 20 Newton per mm square. അതായത് ഒരു 20 Newton per mm square കിട്ടാൻ വേണ്ടിയിട്ട് നമ്മളൊരു 22 Newton per mm square അതിൽ ടാർഗറ്റ് വെക്കണം. ഓക്കെ, 22 കിട്ടണം എന്നുള്ള രീതിയിൽ ചെയ്താൽ മാത്രമേ നമുക്ക് 20 കിട്ടുള്ളൂ. Okay, because why? Because there is always a chance of error, especially climate reasons, maybe due to labors, maybe due to the poor quality of materials. Okay, so to counteract this, you have to multiply the load with a partial safety factor. Okay, so this is a graph which shows the stress versus frequency of loading. Okay, so the Carter's value of the load as discussed are based on the statical data. It is assumed that 95% cases the Carter load will not be exceeded during the life of the structures. However, structures are subjected due to overloading also. Hence, the structure should be designed with the loads multiplying the characteristics load with a suitable factor of safety depending upon the nature of very important. Well, I'm telling that if there is 100 structures, okay, I'm building percentage of that structures will not fail during its life period. or it will be around 50 years or 50 to 60 years. Okay, so I can give you an assurance that I have made everything correct, and 95% of that building will not avoid the chance of failure also. There is a high chance that this structure may also multiply the characteristics load with a suitable factor of safety to prevent the failure of the structure. Expecting, so there is a chance of overcrowding. Okay, so what I'm doing is that this is my characteristic load. I am multiplying it with a partial safety factor. Okay, so I will get a particular value. Okay, I will get a particular value. I will design my structure according to this value. Okay, my structure will be designed according to this value to prevent the failure of the structure. Okay, my structure will be designed according to this value to prevent the failure of the structure. Okay, so that's why partial safety factor is gaining its importance. That is, you have to multiply. That is, to prevent the failure, you have to multiply your loads with the factor safety partial safety factor. Okay, so these are the different types of partial safety factor. Okay, so you can see here the design load is equal to, this is the equation. Okay, so design load is equal to characteristics load into partial safety factor. Okay, so this partial safety factor is also already a derived value. You can see here different types of partial safety factors given. Okay, so for dead load, IL means imposed load or live load. Okay, that means the partial safety factor you are taking is 1.5, then it is 1. For different types of combinations are there. Okay, so all these things we will study once we start doing the problem. Okay, so these are the different types of partial safety factor. So partial safety factor is already derived value. You have to just by hand this value and you have to multiply it with the load. Okay, now coming to another graph that we have to study. Just now we have studied in this we have studied about characteristics load. So the word has some relevance, so we'll see what it is. Okay. So next is we'll study about the characteristic and design stack. What does it mean? Okay, the characteristic strength of a material is obtained as a statistical approach with the strength of the material, which is not more than 5% of the test result is expected to fall. Okay, what does it mean? It means that, for example, if I'm having 100 samples, okay, I'm preparing 100 concrete samples. Okay, 100 concrete samples, and my target strength is 25 Newton per mm square. Okay, my target strength is 25 Newton per mm square. Okay, so imagine that I'm going to build a structure, and that structure, the concrete that I am using for that structure should have a strength of 25 Newton per mm square. Okay, so prior to the construction, I'm checking whether the materials is having proper strength or not. So I have prepared 100 samples. Okay, I have prepared 100 samples of 25 Newton per mm square. Okay, I have taken the mixed design accordingly, and I have taken 100 samples of 25 Newton. Universal testing. Okay, how much of load is an sample 0.8, third sample is having 27, like that value is going. Okay, so almost first 20 samples they are having a value more than 25. Okay, so I have found my 30th sample is having a strength of funded my 30 sample is strength. My target strength is 25. Okay. So what does it mean? Okay, what does it mean? So here you are gaining here we are studying about the term that is characteristic strength of a material. So it means that a material is said to have a particular strength. That is, if I want to say that the 100 sample, I have prepared a sample of 25 Newton per mm square. So I have prepared 100 number of samples of 25 Newton per mm square. It should not, that is 5% of that sample should not have a value below than 25 Newton per mm square. Okay, are you getting my point? അതായത് ആ 100 സാമ്പിളിൽ 5% കൂടുതൽ 25 ന്യൂട്ടൺ പെർ എം എം സ്ക്വയറിൽ താഴെ വാല്യൂ വരാൻ പാടില്ല. വന്നു കഴിഞ്ഞു കഴിഞ്ഞാൽ അവിടുത്തെ എൻ്റെ സ്ട്രെങ്ത്, അതായത് ഞാൻ ഇവിടെ ഉദ്ദേശിക്കുന്ന എൻ്റെ ക്യാരക്ടറിസ്റ്റിക് സ്ട്രെങ്ത് 25 ന്യൂട്ടൺ പെർ എം സ്ക്വയർ ആണ്. അത് അതായത് എൻ്റെ കോൺക്രീറ്റിന്റെ സ്ട്രെങ്ത് 25 ന്യൂട്ടൺ പെർ എം സ്ക്വയർ ആണെന്ന് പറയാനേ പറ്റില്ല. ഓക്കെ, ആർ യു ഗെറ്റിംഗ് ദ പോയിന്റ്? ഓക്കെ, ആർ യു ഗെറ്റിംഗ് ഇറ്റ്? ക്യാപിക് സ്ട്രെങ്ത് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ നമ്മൾ ഒരു കോൺക്രീറ്റ് തുടങ്ങുന്നതിന് മുമ്പ് യു വിൽ സ്റ്റാർട്ട്, വാട്ട് വിൽ യു ഡു? യു വിൽ ടെസ്റ്റ് ദ കോൺക്രീറ്റ് cubes. Okay, for example, forget about the 100 samples. We are taking just 20 samples. Sorry, we are taking just 10 samples. We are taking just 10 samples. ഈ 10 സാമ്പിൾസിൽ 5% കൂടുതൽ നമ്മുടെ ഈ ടാർഗറ്റ് സ്ട്രെങ്ത് വാല്യൂവിനേക്കാളും താഴെ പോകാൻ പാടില്ല. Okay, in case if it goes down, I cannot say that I have achieved a character strength is 25 Newton per mm square. Okay, in case if the 5%, more than 5% of the test results is having a strength below 25 Newton per mm square, it means that my character strength is not 25 Newton per mm square. Okay, so that is called as characteristic strength. That is the strength of the material below which not more than 5% of the test So this is very important term. Okay. Find out the design strength. You will get the design strength of a material. Am I audible now? നിങ്ങൾക്ക് ഇപ്പൊ കേൾക്കുന്നുണ്ടോ? ഇപ്പൊ കേൾക്കുന്നുണ്ടോ? Just respond. Okay. So this is a very very important term. Okay, you have to understand it. അതായത് നമ്മൾ for example ഒരു 30 characteristic strength അഥവാ ടാർഗറ്റ് സ്ട്രെങ്ത് വിചാരിക്കുക. I am preparing 10 samples to test these 30 Newton per whether 30 Newton per mm square കിട്ടുന്നുണ്ടോ എന്ന് അറിയാൻ വേണ്ടിയിട്ട് I am taking 10 samples. Okay, അപ്പം 5% കൂടുതൽ കോൺക്രീറ്റ് സാമ്പിൾസിന്റെ വാല്യൂ 30 താഴെ വരാൻ പാടില്ല. വന്നു കഴിഞ്ഞാൽ we cannot say that the characteristic strength is 30 Newton per mm square. Okay, so that is, so if such Okay, so that is characteristic strength. Okay, if you divide it with partial safety factor, you will get the design strength. Next is you have to study about the stress strain relationship. Okay, stress strain relationship of a concrete. Okay, so how the concrete is responding when the stress is activated. So definitely if there is a stress, there will be a strain. Like, there is stress activate, definitely there you will have a strain. There will be an elongation. Okay, so graphically it is like this. Okay, so graphically if we plot the response of a concrete under stress and a strain, the graph will be going like this. It will be a till here it will be a parabolic, and after that you can see up to the value of 0.002 it will be a parabola, and after that it will be a straight line. Okay, so that is how it is responding under stress and strain. Okay, now you can see different types of strength over here. See FCK 0.6 and FCK 0.6 and FCK divided by 1.5. Three graphs are there. So we'll see what is these three different graphs. Okay, this is strain and this is stress. Okay, so for a value of FCK means characteristic strength. M35 grade, M30 grade is there. So different types of grade. M20 indicates its compressive strength. Static. Okay, അതായത് ആ ഒരു കോൺക്രീറ്റിന്റെ M indicates the mixer. Okay, M indicates okay. So that is, so here FCK, that is FCK will be 20 Newton per mm square. Okay, FCK will be 20 Newton per mm square. Okay, that can, I think almost time now. You can post your name to mark the attendance.